All right, go ahead and set up your journal for today. What we're going to be discussing is equivalent expressions. So the objective is to create equivalent expressions using the properties of operations. So you do not have to copy this down in your journal, but I want to recap what it means to combine like terms, right? So like terms mean that they look alike. So they either have the same variable or they have the same exponent. Okay, so let's think about it in this case. You're going to McDonald's and you order a cheeseburger, you order 2 fries, and you order 3 Cokes, right? And then let's say your friends come and they want fries, they want more cheeseburgers and more Cokes. Are you gonna sit there when you order at the cashier? Are you gonna sit there and order every single one of these items separately? No. To save your breath and to save time and confusion, you're going to combine the ones that are alike and organize it, right? So if we look at it here, we have 1 burger and then 3 more here. So we have a total of 4 burgers, right? We have 2 fries and then 3 more here for a total of 5 fries. And then we have 3 Cokes and another Coke that gives you a total of 4 sodas, right? So when you order to the cashier, you're going to say 4 burgers, 5 fries, and 4 sodas. You're going to combine what looks alike together. So in this case, when we're combining like terms, or as they say here, collecting like terms, we're going to combine the ones that either have the same variable or have the same exponent, okay? And they need to have both. So let's look at this case. We have 4a plus 5 plus 2a minus 3, right? Which ones can be combined? Well, I see that 4a and 2a have the same variable, so I'm going to combine them to get 6a. I also notice that 5 and -3 don't have a variable, right? They both share that fact in that they don't have one. So 5 minus 3 would give me 2. And notice that I use different shapes and different colors to categorize. So you can use circles, triangles, stars, or whatever to categorize like terms. But you always need to remember that if I have an A and an A, they can be combined. But A plus B cannot be combined because they're not the same variable. Even though they're letters, one is an A and the other is a B, so they can't be combined. So go ahead and copy this down in the left-hand side of your journal. We're going to be defining the difference between equal and equivalent, right? So you hear the word equal and equivalent, but they're not actually the same thing, right? So if I tell you that I have a burger is equal to a burger, right? They're the exact same thing. There's no changing the fact that they're the same thing. Equal means that they're the same. Equivalent would be a burger to a cheeseburger. Okay? What is the difference? Well, one of them has cheese, the other doesn't. But at the end of the day, they're still the same thing. They're still a burger. So they're kind of the same thing in that they're food, they're burgers, but just one of them has one little difference. Okay? So another example of equal would be 2 is always going to be equal to 2. Or let's use a fraction example. I think that would be a better one. Let's use 1/2 is always going to be equal to 1/2. Okay? Those are the exact same thing, so they are equal. Equivalent means 1/2 is equal to 2/4, right? Now, they're not the exact same thing, okay? This does not say 1/2. But if I were to simplify that, right, if I were to divide 2 from both, I would be left with 1/2. So at the end of the day, they equal the same thing in the value, but they're not the exact same things. They're not twins. Okay, they're not the same, they're not the same at all. They don't look the same. So that is the difference between equal and equivalent. So now what we need to do is we need to figure out whether or not these two expressions are equivalent. So if you notice, like right over here, we have a really big mess of an expression. Like that looks like a hot mess. It looks like a lot of work, but we're going to solve it. And what we want is we want to see if this side matches this side. So we want this side right here when simplified, this side here when simplified, to look like this. So what are some things that we need to do? Well, first of all, I see parentheses, and I see a number on the outside. And I know that we learned last class the distributive property. So I'm going to go ahead and use the distributive property to distribute that negative 4. So when I go ahead and do that, I'm going to be left with negative 4 times negative 3x, and then plus negative 4, right? I'm bringing that, and negative 8, right? Because you see that's a negative 8. So when I simplify that, a negative times a negative is a positive 12x, right? 4 times 3 is 12, and I bring the x. And then a negative times a negative here is positive, and 4 times 3 is 32. So I got positive 12 plus 32, right? And then I'm going to bring this down, right? There's nothing to be distributed there. So I'm going to bring down minus 4x, and I'm going to bring out plus 8, okay? So I'm going to go ahead and bring all of that down. So now let's look, which terms here can be combined? Well, I have 12x and negative 4x, right? So that is going to give me, when 12 minus 4 is going to give me 8x, okay? And then I have a positive 32, I'm putting a circle around it, and a positive 8. 32 plus 8 will give me 40, okay? So now let's go ahead and bring down this other side. Negative 8x plus 40. Are these two sides exactly the same? Okay. The answer is no, right? One of them has a positive 8x and the other one has a negative. So in this case, no, they are not equivalent, okay? They do not equal the same thing. Now, if this ended up being a negative 8, though, would they have been equivalent? In that case, yes. So when the two sides look the same, then they're equivalent. When they are not looking the same, then they are now not equivalent. Alright, so now we have a really messy problem, and it's really the same process, and I want you to try this one on your own. So I notice parentheses, so I know I'm going to have to distribute, and I notice I have two sets of parentheses, so I'm going to have to distribute twice. And at the end of the day, I want my expression to look like this so that it's equivalent. So go ahead, you may use a calculator, figure out what your final expression is going to be, and then raise your hand to check your answer with an iPrep facilitator. Here are your classwork pages. They are due at the end of the period, so make sure you are moving diligently to complete your assignment on time. They will be graded, collected, and graded at the end of class.